All right, ladies and gentlemen, so one of the types of graphs that we will involve ourselves with is a position versus time graph. So this is position versus time. And this is a graph that shows you where an object is at any point in time. So let's say at this 10-second mark, right at that position, or right at that time, it is 30 meters away from whatever point we set as R0. Here at 20 seconds, we're back down at 0, and here in the middle, we're somewhere in between. And we really just want to be able to do two things with this. The first is find displacement, find delta x from one of these graphs. And if you remember that delta x is our final position minus our initial position. So if we take this time period right here, this 0 to 10 second time period, and we want to find our displacement, we would take whatever x value, right, our y axis is our position. So we take our position at the end, at the 10-second mark, which is 30, and we would subtract our initial position, which was also 30 in this case. So over that section of graph, we have a displacement of 0 meters. And you'll notice that that is a flat line. So flat sections of this type of graph, not flat sign, flat line, means 0 meters as your displacement. So if you have a flat section of one of these position time graphs, you are not moving, right? We're staying constant at that exact same position. But if I then wanted to take the 10-second to 20-second section here, I would say delta x, my final position, right here, my y value is 0. My initial value was 30. So my displacement would be 30 meters in the negative direction. I'm going down 30 meters. So we need to be able to find displacement from this graph, but we also want to be able to find velocity. And to do that, we actually use the slope of that graph. So let me redraw our graph here. And that was at 10 seconds, this was 20, and this was a 30-meter displacement seconds here. So we can also find the velocity because it is the slope of the graph. And that is average velocity. So remember, slope is y2 minus y1 over x2 minus x1. So if I take my y values, which are position, and if we're doing final minus initial, that's really just the change in position over my change in x value, which is time. Delta x over t, that's an equation we have for our velocity. That's sort of how that pans out. So if I take a look and say, all right, what's my average velocity? Average velocity from 10 to 20 seconds. I do my change in position, which before we said was negative 30. So my slope would be negative 30 over the change in time. Well, if I'm just going from 10 seconds to 20 seconds, that is a 10-second change in time. So I end up with negative 3 meters per second. That's saying that every 3 seconds, every second I get 3 meters closer to that initial point. I'm moving in the negative direction there. If I wanted the average velocity for the whole trip, let's say, I'm going to scoot some of this stuff out of the way. For the whole trip, I would still do the same thing. I do my final position, which was 0 meters, minus my initial position, which, as you can see there at the top, is 30 meters. And my time, my final time for that whole trip is 20, and I started at 0. So my average velocity for the whole trip would be 30 over 20, negative because of this negative there. So negative 30 over 20, or negative 1.5 meters per second. So again, for these position time graphs, we want to be able to find displacement by doing the final position minus the initial position. And we also want to be able to get the average velocity for any segment of that graph by taking the slope of the line between those 2 points, doing final minus initial position over final minus initial time.